All right, let's go over problems number 1 and 2. So looking at this is problem number 1. Just to go through if you had any trouble with solving this or how to do this so that you can move forward with number 3. So problem number 1, as I go along in this circuit, I see that as the current comes through, I have 2 resistors. I would call those in parallel. The current comes back and has to go through these. So that becomes in series with these. So we're told the value of each of the resistors. The battery has an unknown but constant EMF or voltage. What is the equivalent resistance of the 3 resistors? And if the current in the resistors R3 is 0.4, what is the voltage of the battery? That's another word for EMF. Determine the voltage across R1 and determine the power dissipated by R1 or used by R1. All right, so I'm going to bounce over to the whiteboard here, redraw our circuit. Right, so that's our voltage. As I said, the current comes through. We have R1, R2, both of which we have the values for, and R3. Right, so here we have R1 equal to 4 ohms, R2 equal to 12 ohms, and R3 equal to 9 ohms. And we also know that the current that goes through here, current 3 equals 0.4 amps. So what we're looking for, if I want to do an equivalent resistance, right? So what I would do here is to say that these are in parallel. So if I get rid of those, my circuit becomes same battery, replace those 2 resistors with 1 resistor. R3 stays the same. I will call this R12, and this is R3, still equal to 9 ohms. So that came from parallel, so 1 over R12 is equal to 1 over R1 plus 1 over R2. So that's going to be equal to 1 over 4 plus 1 over 12, which is equal to 3 over 12 plus 1 over 12 is 1 over R12. So that's 4 over 12. Right? So R12 is 12 over 4. Reciprocating both sides. 12 divided by 4 gives us 3 ohms. So R12 has a value of 3 ohms. These two together here are wired in series, right? So then to get to the next stage, I would say I would use the series rules. So we would have our total voltage, get down to 1 resistor, we will call our total now, which is a combination of 1, 2 plus R3, because 1, 2, and 3 are in series with one another. Not 1, 2, and 3, but 1, 2, subscript of 1, 2. So our total would be 3 ohms plus 9 ohms. My total resistance is 12 ohms. So that's the first answer. Part A, determine the equivalent resistance of the 3 resistors. So now that I have that, I can kind of work backwards to say, okay, if the current here is 0.4, that's the current that comes out of here. So that's still 0.4 amps. And I know that because that's the current that goes through here, 0.4 amps, which must be the current that comes through the 3 and out of the battery. So because those are in series, if I know that that's 0.4, I can say over here, I total equals I12 equals I3 equals 0.4 amps, right? So that tells me the current through each one of those. So if I want to know that current, well, first I wanted to know the EMF of the battery. So getting back to part B was to say, what is V total? V total is I total, R total. I total is 0.4 amps times 12 ohms. So my V total is 4.8 volts. That would be part B, my total voltage. This was A. So the next question, let me make that a little bit smaller so you can see that all. My next question was, what is the EMF or the voltage? Determine the voltage across R1, just this voltage. Well, what I can do is recognize that, okay, if I can find that that's in parallel, because it's in parallel, I can say over here that V1 equals V2 equals V12 in parallel, right? So since I can say I know what I12 is and R12, so since I know I12 equals 0.4 amps and R12 is 3 ohms, then V12 equals I12 R12. So V12, so that's going to be 0.4 amps, right, times 3 ohms. So V12 equals 1.2 volts, which is also equal to V1. And that's part C. So notice that every place I'm working under the picture that matches it. So again, this 1, 2 comes from this section. So I would consider that I follow the rules of parallel when I'm looking at 1, 2. Next question, the power dissipated by R1. So for part D, P1 equals I1 R, or V1, P equals IV, but I don't know the current. So I don't have the current through I1. What I do know is the 0.4 comes here and it's going to split. So this is 0.4, but I don't know the current that goes through each of these paths because that's going to split up. It comes back together to be 0.4. So you always want to picture, like the marbles, again, flowing through the circuit, what's going to happen. But I can say that I1 off to the side, I don't know I1, but it's going to be V1 over R1. So I'm going to write this power equation as V1 squared over R1. And since I know V1 and R1, I can just plug that in. So that's going to be 1.2 volts squared divided by the resistance R1 is 4 ohms. So divided by R, 4 ohms. So P1 equals, so we get P1 equal to 0.36 watts. Now to check, so my total voltage was 4.8. The voltage of 1, 2 is 1.2. That should leave the voltage of this. I should find the voltage of the 3 to be 3.6. So let's try that out. So what is, I'm going to work underneath this second picture. V3 is going to be I3 R3. I3 is 0.4 amps. R3 was 12, right? No, I'm sorry, 9. Yep. So 9 ohms, amps. V3 is 3.6 volts. So I think I did my work right because V total is going to be equal to V12 plus V3. 4.8 volts equals 1.2 volts plus 3.6 volts. So that's just a way of checking to see if I think I did it right. My numbers all seem to be checking out. And that is problem number 1. All right, continuing on, I'm going to open up a new whiteboard to take a look at problem number 2. So we'll look at problem number 2 here. All right, so here we have problem number 2. Just like that. Student is provided a 120 volt battery, 4 resistors of a 130, 20, and 10. Plenty of wire, no, that doesn't have resistance. Using all the components, draw a circuit in which the resistance has a non-zero current flowing through, but in which the current from the battery is as small as possible. Part B is where's the current the most. So if I want my current, so this is problem number 2. If I want my current to be as small as possible, right? Whoops. V equals IR. So I equals V divided by R. So as R increases, I decreases. So that's what you want to be thinking here in this problem. Voltage is constant because that's what's coming from your source. We're going to assume that we can't change the power supply. So the voltage is constant. So current equals V divided by R. So the R is the least when we're in series, or is the most when you're in series. So for part A, you would want a series circuit. So that R is maximum. So we would just draw a circuit with all of those in series, right? We have a 100, a 30, a 20, a 10. It really doesn't matter if you put them all on the same line or if you just put them all on one side or something like that. So that would be part B. You'd want that to be all in series. I'm sorry, part A. In part B, for the maximum current, you want R to be as small as possible. Therefore, we want that to be in parallel. So if I were to draw that circuit, we'd want all those in parallel, right? 100, 30, 20, and 10. All should be in parallel. And that's it. Easy enough. So that's the thought behind it, right? So again, looking at Ohm's law, to make current as most, you want R to be as least. To make current as least, you want R to be as big if you have a constant voltage. So that's in the case when you have a constant voltage. Okay, so that's A and B. Part C then asks a new diagram to our circuit, right? So in part C, if I now connect these such that we have our 12 volts, but I come along and I have to choose, do I want to go through the 100 ohm or do I want to branch off and go through the 20? Then I have to go through the 30 and come back together, right? So this is our 20 and our 30, come back together and possibly go through our 10. So again, think in terms of current. If the current comes out of the battery, it has to split up at that point. Some of it will go this way and some of it down this way. But it will come back together right here. And so this current is the same as our total. So the I total equals the current through the 10, right? So it says determine the current in the 10 ohm resistor. So I'm going to need to find the total current. So what I want to do first is recognize that, okay, this part over here is coming from series. So the first equivalent circuit I can be drawing is to say, let's keep the 100, but let's call this one, I'm going to call this R1, R2, R3, and R4. So this would be R23. As this comes back together, and this again is our 10 ohm. So because it's in series, R23 is equal to R2 is equal to R3. That's going to, not equal, I'm sorry, plus. So R2 is 20 plus 30 gives us 50 ohms. So I have a 50 ohm resistor here. So then I will say that the 50 and the 100 are in parallel. So now I can get rid of that, and I'm going to call that R123. And then I still have R4, which is 10 ohms. So 1 over R123 equals 1 over R1 plus 1 over R23. Because they came from parallel. So resistance 1 is 100 ohms plus 1 over 50 ohms gives us 1 over 100 plus 2 over 100. So R 1 over R123 is equal to 3 over 100. So then R123 is 100 divided by 3, which is 33.3 ohms. So that's how much this is, right? 33.3 ohms. So now my final thing is to say, add those two together to get our R total, right? So our final circuit would just be with one resistor that came from series. And we would say R total equals R123 plus R4. So that's going to be 33.3 ohms plus 10 ohms. So my total resistance is 43.3 ohms. Now you weren't asked specifically for that. We found that because what we do know, what we do know there is V total. So over here we can say V total equals 12 volts. R total equals 43.3 ohms. So what is I total? What is the total current coming out? That total current is going to be total voltage divided by total resistance. So that is 12 volts divided by 43.3 ohms. I believe that I total comes out to be 0.28 amps. 0.28 amps is our total current. And finally, you're asked to find the total power. Total power is going to be total current times total voltage. So that should be 0.28 volts times your total voltage of 12 volts. Your total power, 0.28 times 12, gives you 3.33 watts. Shrink that all down. Problem number 2. All right, hope that helps.